Hey, welcome back to part 2 of regular expressions in Python. Not only are we doing some examples of regular expressions in Python, we're also just going through what are regular expressions, what is the different syntax of regular expressions, what's it mean, and hopefully you're finding these videos useful. And if you are, please consider subscribing. That way you can keep up with content in the future. And if you're also bored, check out my website, codingunderpressure.com. I'm adding content on there all of the time. I'm trying to make an article daily. I don't know if that will keep true or not, but yeah, check that out. It'll be linked down below if you're interested. And lastly, today we're going to talk about sets of characters in a regular expression. So we're looking at this syntax now, the two square braces, and what that entails. So back to our regex101.com. This is our website to test different strings, and we can create our own patterns, regular expression patterns, and see if they perform the way we want them to. So in the last video, we talked about qualifiers. So here I have one or more pound signs is what I'm asking for. A match with one or more pound signs and one or more B. In our case, we have a match right here because there's a pound sign and a B. We also talked about the asterisk. We talked about the question mark and obviously the plus, as you see here. Today, I have a receipt in Python. So let's say we read in some data, and the receipt looks something like this. I have soap, which is $1, bleach, which is $5, cheese, which is $3, chips, dog food, 15, and we want to gather all of the dollar amounts and add them up. And how are we going to obtain those dollar amounts? I want to do that using regular expressions, because sure, we could probably code up something if we knew that it was the last item in each line and that there was a space, in front of the dollar sign. We could probably do this in other ways, but let's say there isn't. Let's say there's, for some reason, user input error. There's a period right here, or there's a tab, or, things we don't account for. The only thing we do know is that there is a dollar sign and a numeric amount, which tells us how much that item cost. And we also can't, by the way, split this by spaces because there's a space here and there's a space here. So this one would ruin that rule too. We would look for the second item if we did a split by line, and we'd get food instead of $15. So let's copy this first line here, soap, $1. And I'm going to show you how we can use those square braces or sets in order to help us out with this example. So a set is saying a character can live in these particular sets of characters. I know that sounds a little bit redundant, but an example would be better. So let's say I have square braces, and inside I have the letter S. So I want to match wherever there is something in this set. In this case, there's only one character in the set, it's an S, so we have a match with the S in soap. But I can also do A, character A. And notice I didn't put a comma, I didn't put dash or anything like that. I just put S and A, and this isn't saying find us where there are an S and A next to each other. That would be without the square braces, an S and an A, which there aren't any matches. This is saying the character is within this set of characters here, S or A, and that's why we have a match on both S and A. If I also did a P, we'd have a match now on P, but we can go a step further. We can say any character between A through Z, let that become a match. So we have a match now, as we see on the right, for S, O, A, and P, because those characters live between A through Z. Now notice they're all lowercase. If we change this to capital S, we're not going to have a match there because capital S is not in this range in our set. And regex101.com is nice enough to tell us it is case sensitive. So if we wanted to do uppercase as well, beside the set range here, A through Z, we could also do capital A through capital Z, and now see the S is found as a match. And the same can be applied with numbers. So if I want to do 1 through 9, now we have the number 1 as the match. And we can also go 0 to 9, and if I change this to 0, that one's now a match as well. So we can put any character we like or any range that logically makes sense in this set. So 0 through 9 or A through Z, and it'll find matches for any of those cases except capital S because, like we said before, this is case sensitive. Lastly, I want to show you the not set. So if we want to say the opposite, it's not any of these characters, we can do the caret, I think it's called, or the number above the 6 on your keyboard, and then let's say O, lowercase o. So this is saying where it's not O. And notice everything but O is now highlighted because it is now a match. And then kind of to tag along with yesterday's video, let's get rid of the not. Now we have O, there's a match for O, but let's say we want O 2 times, or anything in this set needs to be 2 times or 2 together. Well, there aren't 2 of anything in this set side by side, but if I change it to O or A, there is an O or an A together exactly 2 times. So those get highlighted, or this one gets highlighted. And so, yeah, this is great and all, but what does this mean for us collecting the dollar values from this makeshift receipt? So what we can do is let's get rid of the 2, because this can be any number of digits. It can be $1,000. It can be $10,000. It can be, let's check this. Is that a million? $1 million. We're not going to specify an exact number. So I'm going to put a plus, because if you remember, a plus means there's 1 or more occurrences of whatever's in front. And then inside, I'm going to say 0 through 9. And now it highlights the number value in front of the dollar sign. But I'm thinking to myself, what if the product has a number in it? So let's say the product's called number 1 soap. We have 2 matches now, because maybe it wouldn't be spaced like this. Number 1 soap is the name of the product. There's a 1 now in the name, number 1 soap, so it matches because it matches this set. It's from 0 to 9, and there's at least 1 instance of it. And then this number also matches. But as I stated before, we know for a fact that all of the dollar amounts are going to start in our receipt with the dollar sign. So what I can do now is I can put a dollar sign in front of the set, meaning that it starts with a dollar sign. There's some kind of amount of numbers, at least 1 of this range of numbers, and that'll be our dollar value. However, notice we're not getting a match, and that's because dollar sign is a special pattern character. And so to ignore that and just say, we mean explicitly the dollar sign, not what the dollar sign means, we can put a backslash in front of the dollar sign, and now we have a match. Because we have a dollar sign, we have a set of numbers, and those numbers are there at least once. And so let's bring in the whole receipt now. This is a good way to debug. I'm going to copy all of this, and I'm going to paste it in here. And notice now all of the dollar values are highlighted. So let's copy our regular expression, go back to Python. We have our receipt. Let's create a new variable called results, and we're going to say regular expression dot find all. The first parameter is our pattern. So this, the pattern that we tested on that website. And then second argument is going to be our string we named receipt. Now if we print results and we run this py-main, we now have all of the dollar amounts from that receipt. So lastly, what if we want to add all these up? This is kind of like a bonus part of this video because it really doesn't have anything to do with regular expressions, but we can do results is equal to the list comprehension x dot replace, because we no longer want that dollar sign anymore. We're going to replace the dollar sign in each value with just nothing for x in results. And then lastly, we want to change this from a string to an int. So we're going to change each of them to integers. And now if we print this, we now have 1, 5, 3, 2, and 15. And we can do print the sum of results. If I can type today, there we go. And lastly, here's our total sum, $26. So that's how we took the dollar values from a receipt and found all of those dollar values with regular expressions, took the dollar sign out, turned it into integers, and summed them all up and printed out the sum. And I think this right here was a good example of how you can use regular expressions, right? If I have more gibberish after the dollar, for some reason, let's say really bad user input like this, and we got to run this again, the result's going to be the same because our pattern still holds true. We're only grabbing this piece out of each line. And so I know we did a lot in this video. Not only did we talk about sets and what they mean, but we also did our first real example of regular expressions with a fake receipt to get all of the prices and add them all up. So thanks so much for watching. Hopefully you found this useful, and I hope to see you in a future video.